Hello everyone. Welcome to the graphics programming virtual meetup. Today we will continue talking about the physically based rendering book, and we are covering 8.3 and 8.4, which is sampling, which we continue talking about sampling, but now it's the code rather than just a theory. So PBRT has a sampler interface, which is useful because there are a variety of sample generation algorithms. And the sample points are used in multitude of ways, ranging from determining the points on an image plane to trace a shadow ray to and at which point on it the shadow ray should terminate. Yeah. And the benefit of carefully crafted sampling patterns are not just theoretical. I guess everyone know it, while like we talk about blue noise previously a lot. So yeah, just say there's two images. This one is poorly sampled and this one is better sampled. You can see the noise get reduced just by change the sampler. At least like visually, the noise is much better in this one compared to this one. So the task of a sampler is to generate a uniform d-dimensional sample points, where each coordinate value is ranging from 0 to 1. And total number of dimensions in each point is not set ahead of time. So samplers must generate additional dimensions on demand, depending on the number of dimensions required for calculation performed by the light transport algorithms. So for example, in this case, we generate the XY, which is the location on the pixel. And then T is the time, UV is for length, I think. This is, they don't say anything, but anyway, and additional parameters are just for the integrator. If they need additional random numbers, then we just generate additional dimensions for that. So all the samplers save the MLT sampler are defined in this chapter. Like in later sections, we will talk about those, but not today. So sampler specify numbers of samples to be taken in each pixel and return this value via samples per pixel. And most samplers already store this value as a member variable. So it's just a simple getter. So when an integrator is ready to start working on a given pixel sample, it starts by calling start pixel sample, providing the coordinates of the pixel in the image and the index of the sample within the pixel. The index should be greater than or equal to 0 and less than the value returned by samples per pixel. Because we can have multiple samples per pixel. Integrator may also provide the starting dimension at which the sample generation should begin. So this method serves two purposes. First, some sampler implementation use knowledge of which pixel is being sampled to improve the overall distribution of samples. So yeah, so for example, ensuring that adjacent pixels do not take two samples that are too close together. So we need the knowledge of where the sampler is, basically. This can substantially improve image quality. Second, this method also allows sampler to put themselves into a deterministic state. I guess like XY, yeah, because they use this information to initialize the seed of the RNG, I think. Then and to make the PBRT totally deterministic, which is really helpful for debugging. So if PBR, for example, if PBRT crashed in the middle of a lengthy run, debugging can proceed starting at the specific pixel, and then the pixel sample index where the render will crash, and with a deterministic render, the crash will reoccur. That's a really nice property with all the Monte Carlo stuff going on. Yeah. And just being deterministic is a really good property for debugging. Integrators can request dimensions of n-dimensional sample points, one or two at a time, via get1D and get2D methods. And 2D sample value could be constructed by using values returned twice by using get1D. Some samplers generate better points if we generate them together. The integrator does not, sorry, sampler does not have support for 3D or higher dimensional sample points because the PBRT does not need to use it. Yeah. So in those cases, multiple value from lower dimensional component can be used. And a separate method, getPixel2D, is called to retrieve a 2D sample. Used to determine the point on the film plane that is sampled. So some of the sampler implementation just call this, but some others you do some special handling for that, assume to get a better distribution just for like location, the offset on the pixel. Each sample coordinate must be strictly less than 1. It is useful to define a constant 1 minus epsilon represents the largest representable floating point value that is less than 1. A sampler will sometimes clamp sample value to be no larger than this. It is just a constant. Sharp edge of those interfaces is that code that uses sample values must be carefully written so that it always requests sample dimensions in the same order. Consider the following code, like the first dimension of the sample will always be passed to a and yeah, this is conditional. I guess this is just for all those kind of generator like interface just doing this kind of thing can cause problems. Yeah, this will thwart efforts by the sampler to provide well-distributed sample points in each dimension being evaluated. And sampler also has a clone method, which returns a copy of the sampler, because sampler carries various states. So it's unsafe to use samplers across threads. So the next part, well, let's see what the comment. Reminds me of React hooks. Yeah. But I guess at least for this is really common requirement. It's like anytime you have this kind of generator or like lazy iterator kind of thing, you need to be careful about code like this, basically. So now independent sampler is the simplest possible correct implementation of the sampler. Yeah, you can also just return constant, which will not be correct. Return independent uniform sample values of each sample request without making any further effort. So it's basically just white noise. Independent sampler should never be used for rendering if image quality is a concern. I guess all of us, when we write retracer, we start from here, right? But it's not good for production. But it is useful for setting a baseline to compare against better samplers. Independent samplers take a seed to use by initializing the PRNG. Setting different seeds make it possible to generate independent set of samples across multiple runs of the sample render, which can be useful when measuring the convergence of various sampling algorithms. And yeah, they use an RNG class to generate sample coordinate values. Independent sampler always give the same sample value for a given pixel sample. It is important to reset RNG to a deterministic state rather than, for example, leaving it in whatever state it was at the end of last pixel sample. They take advantage of the fact that RNG in PBRT allows not only for specific one of the 2 to the power of 64 sequences of pseudo-random values, but also for specifying I see, offset in that sequence. The implementation below chooses a sequence deterministically based on the pixel coordinate and the seed value. Initial offset into the sequence is found based on the index of the sample, so that different samples in a pixel will start far apart in the sequence. If a non-zero starting dimension is specified, it gives additional offset into a sequence that skip over early dimensions. We just set the sequence advance. So given a city of orange, the implementation of the method that return 1D and 2D samples are trivial. Get2D uses CPAPA's uniform initialization syntax, which ensure that two call to uniform happen in well-defined order, which they can also do that by just using two variables, whatever. Yeah. All the methods for analyzing sampling patterns from the previous sections are all in agreement about the independent sampler. It is a terrible sampler, yes. Independent uniform samples contain all frequency equally. So it's white noise. They do not push aliasing out to higher frequencies. The discrepancy of uniform random samples is 1, which is, it's worst possible. These samplers only saving grace come in the case that integrating a function with a significant amount of energy in its high frequencies. In that case, it does about as well as any of the more sophisticated samplers. Yeah, I think we're done. Any questions before we end the recording? Okay.